I'm going to actually make flashcard for the mean value theorem. Let's go to it. Okay, go ahead and make your flashcard number 5. I'm going to be on this for 60 seconds. Go. I'm recording. If ever you end up not having enough time, could we always go to my website? And then you will see flashcards as one of the drop downs. Okay, I'm going to read what the flashcard says. It's the mean value theorem, and it has to do with parallel lines. And your common acronym is MVT. So our first two condition is the function must be continuous on the closed interval, and it must also be differentiable on the open interval. And you may make whatever graph that looks like a curve to you. So tangent line goes through 1 point, called the IROC, and secant line goes through 2 point, called the AROC. And we should be familiar with the formula somewhat from our the derivative one. So it says f prime of c is equal to f of b minus f of a all over b minus a. The first one is always a tangent. Second one's always secant. And for this lesson, we're going to be doing IROC is equal to AROC using Desmos. Okay, I'm going to wait 20 more seconds on this one. Can y'all see the tangent line and the secant line is actually parallel? So on yours, make it look parallel as well. Okay, when you're done on your notes on 3.2a, go ahead and read the top portion to yourself. It's basically the flashcard. Again, 3.2a on the top, read that to yourself. And think about how to plug in our blanks from the notes on the top. Okay, if you're still on the flashcards, I'm going to change it in 5 seconds. All right. I want you to put a big star next to our bolded underlined statement. Very important. So it says the slope of the blank line is equal to the slope of the other line. We said tangent line is equivalent to what line? Secant. Tangent line is equivalent to the secant line. And specifically, it was IROC is equal to the what? AROC, and ROC stands for rate of change. So we're going to write on this one. The first one is instantaneous. Instantaneous. Rate of change is equal to the average rate of change. And that's exactly what you have on your flashcard. Let's go ahead and read these two phrases back to back 3 times. Go. Out loud. At least 3 times. So in summary, when I say tangent line, it is instantaneous. And when I say secant line, it is what? The average. Keep that in mind. So let's move on to our first one right here. I want to worry about example number 3. All right, Aaron, let's read example number 3 out loud, please.
Apply the mean value theorem to f of x equals 5 minus 4 over x on the interval 1, 4. Find all values of c in the interval a, comma b, such that f prime of c equals f parentheses b minus f of a over b minus a.
Okay, let's highlight mean value theorem. So if it says to apply mean value theorem, we're doing IROC is equal to the AROC. So I'm going to start highlighting some important pieces. F prime of C, what is that representing? AROC or the IROC? IROC, very good. So I want you to write IROC is equivalent to, then that means my other side, this one must be not the IROC, but the what? AROC, very good. And that will be a common term I use for this chapter. So IROC is instantaneous. It says to find the derivative. So let's start by rewriting our function. So on this one, we want to bring this one up. So let's rewrite it as f of x is equal to 5 minus 4x to the power of negative 1. And before we apply this, we have to go ahead and mention our 2 conditions from our flashcard. We have to say the first condition, the function is continuous on the open or closed interval. Look at your flashcard. Closed interval 1 to 4. And then the function is differentiable on the closed or the open. Open. And if you're thinking, why is it open? It's because at the end point, you cannot find the slope. That's all that it means. So here we go. We rewrote f of x. So we know f prime of x is going to be the derivative. Evan, go ahead and give me the derivative of the original function after we wrote it. Take the power and the constant and multiply. Mm-hmm. Isn't that simply 4x to the what? Negative. What's one less of that current power? Negative 2. We're right here. Multiply those 2 and make 1 less power. I'm going to move on. And then the AROC is going to be our average rate of change, which is f of 4 minus f of 1 all over 4 minus 1. And I'm going to go ahead and rewrite our prime. Let's write this as 4 over x squared. And then when I plug things in, now we're looking at the graph. Polly, will you read to me the y value when x equals 4 on the graph? 4, very good. I'm not going to go back to the graph. Minus f of 1. What's the value of f of 1? When x equals 1, what is a y value? 1. All over 4 minus 1. And these 2 numbers being the same is simply coincident. So we have 3 over 3. What's the easiest number instead of 3 over 3? 1 over 1. We are going to set these 2 equal to each other, applying algebra. So here we go. 4 over x squared is equal to 1 over 1. And let's cross multiply. When I do, I get x squared is equal to, how many is 4 times 1? 4. And then we are going to square root it. And when I square root, we get how many numbers? We actually get plus or minus, right? Okay. The good news on this one is my interval is between 1 to 4. So which number is the only one I want? Positive. And I'm going to prove something to you. And it says it was asking us for value of c, even though we found x. They mean the same thing. So if you just write x equals 2, that's fine. But do know that the question asked us, what is the value of c? So writing c equals 2 is even better. So here's my proof to you. I am going to go to 2. Everyone go to 2. And also go to 1 and 4. On the AROC, if I connect these 2, here's my line right here. When you apply the mean value theorem, the secant line and the tangent line will always be parallel. So I want you to make a line that's parallel to the other one. And that's always going to happen. So when you connect your lines with the secant, and it's not parallel, then most likely your answer is incorrect. Okay? So again, mean value theorem means two lines are parallel. A-rock and I-rock are what to each other? They're equal. All right. Now let's go on to number 5 is where we are going to need Desmos. All right, for number 5, Caitlin, go ahead and read.
A company introduces a new product for which the number of units sold S is given by S of T equals 200 times 5 minus 9 over 2 plus T, where T is the time in months.
Okay, let's go ahead and kind of make our graph in detail. So T is in months. And then we have S of T is our Y value. You can go back to the graph at some point if you want. If you want to just stick with Desmos, I'm okay with it as well. Okay, Julie, let's read part A.
Find the average rate of change of S of T during the first year.
Okay, let's highlight average rate of change. Is the average rate of change I-rock or A-rock? Let's all write A-rock on top. It is the A-rock. And it's A-rock the prime or the average? It is the average, hence the word. And then let's see what interval we're looking at. We are looking at it from the company with time in months. So when is a company starting and when are we going to stop? Okay, at 12 months, correct? So let's put on here, when I start the company, it'll be 0 to 12. Because the first year will be from 0 all the way to 12, right? Not from 1 to 12, because the first month is still included. So let's write on here S of 12 minus S of 0 all over 12 minus 0. And since I gave you the function, we're going to simply plug it in. It's going to look messy, but we're going to let Desmos do all the work, all right? So again, it's going to be messy. So we are plugging it back in here in case you're thinking, where is my messy function? Right here. So here we go, right with me. So we have 200, leave it alone. Do not compute as you go, because we all make silly mistakes. Open up your parentheses. 5 minus 9 all over 2 plus 12. Pretend you don't know 2 plus 12. And then our average rate of change is minus. Now we're plugging in 0. So 5 minus 9 over 2 plus 0. Pretend you don't know 2 plus 0. All over 12. So on Desmos, write it exactly like this. Go. If you start with the fraction, it'll give you a space for the top and the bottom. You have it?
Yeah.
Wait on it. I wonder if the siren could be recorded on this. I should listen. Again, make it look exactly like what's on your paper. And give me a clean fraction on this one. And I'm going to wait 7 more seconds. Help each other on the buttons. Did y'all get something over 7?
Yeah.
What over 7? 450 over 7. And let's write on here, this is representing units sold per month. Units sold per month. So again, plugging things in, not a problem. And then let Desmos type it all in, okay? All right, now let's go to part B. If you're ready on part B, give me a thumbs up. Okay, Mackie, go ahead and read part B, please.
During what month does S prime of T equal the average value during the first year?
Okay, so we're looking at during which month? So we're looking at the I-rock equal to the A-rock. Do we all see that? Okay, again, let's write that out. We're looking at I-rock is equal to the A-rock, and that's applying the mean value theorem. Don't we already know the AROC is 450 over 7? Just save that in your head for now. Let's worry about the IROC. For the IROC, what I'm going to do is the following. Let's rewrite the original function. Because I want to make this one a little bit easier. Can we go ahead and distribute the 200? Let's do that. So when I distribute my 200, we all know 20 times 5 is how many? 1,000, which basically we don't need in the end, because when I derive this, I don't need it, right? Minus 200 times 9 is 1,800 over my denominator. And since my variable's on the bottom, what do you think I'm going to do? Bring it to the what? The top with a negative power. 2 plus t to the negative 1. And then do y'all see that we're going to apply chain rule right here? Chain rule right there. Do I care about the 1,000 when I derive? Absolutely not. So s prime of t. All right, let's see. When I multiply negative 1 and negative 1,800, how many is that? Positive 1,800. And you keep the inside. What is 1 less of negative 1, everybody? Negative 2. Now when I derive the t, do I have to write times 1? No. So let's make this in a better form. You can leave it like this since we're using Desmos. But just because, for teaching purpose, I am going to rewrite this with the positive power. So here I go. This is my IROC. Do we all see that? Did we find the AROC already was 450 over 7? And I think I want to go ahead and use cross multiplying. We can type this in as it is, okay? If you want to, you can, but just because we're in math, let's go ahead and take it step by step. Let's cross multiply next. We have 450 times 2 plus t to the power of 2. And then, what is it when I multiply 7 and 1,800? Type that in, somebody. 12,600. And then we're going to divide it by what? 450? Let's all divide that ugly number, 12,600 by 450. Okay, someone type that on Desmos. 28. Was it clean?
Yeah.
Nice. Okay, 28. Okay, now we need our little messy decimals here. Let's square root. And I only care about the positive answer on this one. Okay, someone type in square root of 28. Okay, let's go 3 decimal places since that's a norm for AP exam. 292, very good. And then lastly, we're going to subtract what? 2? Go for it. So we have 3.292 months. So question on this one. Is 3.292 considered month number 3 or month number 4? Month number 3. So you guys are seniors, right? This is your year number 4, correct? Does that mean you already finished year number 4? No. So this one should be month number 4. What? Month 4.